All right, let's talk about architecting identity on Google Cloud. If you get this right, your cloud is secure. But if you get it wrong, you're basically leaving the front door wide open. So today, we're going to build a rock-solid strategy right from the ground up.
Before you even think about writing a single line of code, you have got to answer this one simple question. Who holds the keys to your cloud? And I'm not just talking about logging in. I mean controlling every single action that can be taken on your resources. Nailing this is the foundation of real security.
So here's our game plan. We'll kick things off with the big picture of access control. Then we're going to break down Google's IAM system into three simple parts: the who, the what, and the how. We'll even walk through a real-world example to see it in action, and then wrap up with some crucial best practices. Let's dive in.
Okay, first up, controlling cloud access. Before we get into all the technical nuts and bolts, let's just be crystal clear on why this is the absolute cornerstone of cloud security. Think about it. In any cloud environment, you've got developers, you've got applications, automated systems. They all need different levels of access. So how do you manage all of that without it turning into total chaos? Well, Google's answer is a system called IAM. That's Identity and Access Management. And its entire job is to solve that one central problem, defining exactly who can do what on which specific resource. So let's start breaking down that puzzle. The very first piece you need to understand is the who, identifying every single person and every service that needs access. In the world of IAM, we call these members. A member is really just any identity that can be granted access. Let's imagine your cloud is a super secure building. A member is anyone or anything that comes up to the front desk and asks for a key. And that could be a person, or, as you're about to see, it could even be a robot like one of your applications. As you can see, members really come in three main flavors. First, you've got your users. These are individual people with your Google accounts. Next up, you have groups, which are, you guessed it, collections of users, super useful for managing entire teams at once. And then there's this big one, service accounts. These are those robots we were talking about, special identities made just for your application so they can talk to other cloud services. Okay, so we figured out who needs access. Now we need to define what they're actually allowed to do. And that brings us to the second building block, roles. A role is just a collection of permissions. That's it. Think of it like a keycard that's still sitting in the box, not assigned to anyone yet. It just defines a set of capabilities. One keycard might only open the front door, while another one is a master key that opens every single room in the building. The role just defines the potential access. Now, this slide shows a really, really critical idea. Over on the left, you see these basic roles: owner, editor, viewer. You should think of these as sledgehammers. They grant super broad access to your entire project. Very powerful and honestly pretty risky. But on the right, you have predefined and custom roles. These are like scalpels. They are granular and specific, like Cloud Run Invoker. The biggest takeaway for security is to always favor the specific granular roles on the right. All right, so we have our who, the members, and we have our what, the roles. Now we have to actually connect them. This is the how, and we do it with something called a policy. A policy is the rule that brings it all to life. It binds a member to a role, and that binding is what actually grants the permission. So back to our building analogy. The policy is the moment the security guard actually hands the key card, the role, to a person, the member. That action right there is what makes the access official. So the process is actually really simple and logical. Step 1, you choose your member, maybe a group of developers. Step 2, you pick the specific role they need, like Cloud Run Admin. And step 3, you bind them together in a policy. That's it. You've just created a real enforceable rule. Okay, theory is great and all, but let's see how this stuff actually works in practice. We're going to walk through a really common real-world scenario. So imagine a team is building a new application. They're using Cloud Run to host the app itself and Cloud SQL for the database. A pretty classic setup, right? So the question is, how do we give them the permissions they need without giving away the keys to the entire kingdom? Now take a look at this table. Notice what we're not doing. We are not giving the developers the big, scary editor role. Nope. Instead, we put them into a group, and we give that group the very specific Run Developer role. This lets them deploy and manage their app, but nothing else.
And then for the application itself, we use its own service account and we grant it the Cloud SQL client role. That way, the app and only the app can talk to the database. This is exactly what we mean by the principle of least privilege.
So now that we've seen how all the pieces fit together, let's talk about some absolutely essential best practices to make sure you're locking your cloud doors the right way.
Here's a quick checklist you can use for any new project. First, and most importantly, always apply the principle of least privilege. Give only the permissions that are absolutely necessary and nothing more. Second, please manage users with groups, not as individuals. It's way more scalable and a lifesaver when you need to audit things. Third, give each application its own dedicated service account. And finally, I can't say this enough, avoid those powerful basic roles like owner and editor in your production environments.
And this is why it matters so much. Security isn't just about trying to prevent a breach, it's also about containing the damage if one happens. As the slide says, when you grant only the minimum permissions, a compromised account has a tiny blast radius. But what happens if an owner account gets compromised? Well, the blast radius is your entire project. It's game over.
Okay, let's quickly run through 3 super common mistakes, we call them anti-patterns, that you have to avoid. The first one, as we've been saying, is using those basic owner or editor roles. I know it's the easy button, but it is dangerously insecure. It's like giving every single employee a master key to the entire office building. You just wouldn't do it. Number 2, avoid assigning permissions directly to individual users. I know it seems faster in the moment, but what happens when somebody leaves the team or changes roles? You have to go on the scavenger hunt to find and remove their permissions one by one. It becomes a total management nightmare. Just use groups. It's clean, it's simple, you'll thank yourself later. And finally, this one is a huge red flag. Avoid downloading service account keys. These keys are basically permanent passwords for your applications. The second that file is on a developer's laptop or checked into a code repository, it is a massive security liability just waiting to be exposed. Seriously, whenever possible, just let Google Cloud manage these identities for you automatically. So let's wrap this all up with the single most important takeaway. A strong IAM strategy has to be proactive. It is not some feature you just bolt on at the end, and it is definitely not something you figure out after a security incident. It has to be part of your cloud blueprint from day one, just like the foundation of a building. Which really just leads us to one final question for you to think about. Now that you know the rules, the who, the what, and the how of IAM, take an honest look at your own projects. Is your cloud's front door truly locked? Or is it maybe just a little bit ajar?